Hello students, welcome back to today's class on playing with numbers. In the previous class we started with playing with numbers and we discussed different divisibility rules, and in today's class let us try to continue with the same topic and we'll discuss more divisibility rules. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So in the previous class when we're discussing about divisibility rule, we started with the divisibility by 2. That means how to find whether a given number is divisible by 2 or not. And for that, the simple shortcut we have derived, we obtained is that the number should end with 0, 2, 4, 6 or 8, or simply we can say that the number should be even number. The number should be even number. All this we have discussed in the previous class, okay? Even number, yes. Even number, yes. Odd. How can I say even or odd? With the last digit. 2, 7, no, 8, yes, 9, no. So all these numbers are divisible by 2. All these numbers are divisible by 2, right? In the same way, let's move for the next question. Next rule, divisibility by 3, where the sum of the digits should be a multiple of 3. The sum of the digits should be a multiple of 3. And we discussed a lot of examples, correct? So what's the first number we are having? 126, 6, 7, 8, 9. Sum of the digits is 9, and yes, it is divisible. It is divisible by 3. It is divisible by 3. Okay, 9 plus 3 plus 3. How much is that? 15. Yes, sum is divisible by 3. In that way, we have discussed all this. And after 3, we also discussed about 6, where it should be multiple. It should be divisible by 2 as well as 3. Divisible by 2 as well as 3. 504. Divisible by 2. Yes. 5 plus 4 is 9, divisible by 3, yes, and so we can say that it is divisible by 6. Okay, so this is about divisibility by 6, and we also discussed about divisible by 9, where just like 3, where the sum of the digits should be a multiple of 3, here the sum of the numbers should be divisible by 9, right? 504, again 5 plus 4 is 9, yes, it is divisible by 9. In that way, we have completed this table, right? And after that, we discussed divisible by 5, where the units or the ones digit should be 5 or 0. Should be 0 or 5. And 5045 is 5, yes. 0, yes. 9, no. 5, yes. So that is how we discussed about divisibility by 5. And after that, we are yet to start with divisibility by 10. Okay, it's very easy and everyone already knew that, okay, that any number ending with 0 is always divisible by 10. Any number ending with 0, okay, numbers with 0 at one's place are divisible by 10. Are divisible by 10, okay. 50450, 0, yes. This 0 again, yes. 5, no, right. Here it is 0, here it is 0, it is 5. But this divisible, but 5 is not divisible by, to say, at one's place we should have only 0, but we have 5 here, so we can say that it is not divisible by 5. Divisible by, it's not 5, it is divisible by 10. Okay, it is divisible by 10. Right, so let's move forward for the next one. So, number divisible by both 5 and 2. Number which is divisible by both 5 and 2 is divisible by 10. Is divisible by 10. Okay. So let's move ahead. Let's try to see the divisibility by 4. It's very important. 2 we discussed, 3 we discussed, 4 we are going to discuss, 5 we discussed, 6 is done, 7 is not done. We are going to further cover it later. 8 we are going to cover it later, and 10 is also done. So let us try to quickly cover how to find the rule for 4. A number is divisible by 4 if the number formed by the last 2 digits, is divisible by 4. Only last 2 digits enough. No need to go for all the other things. Last 2 digits. See carefully here. 50450. Just tell me, is 50, the last 2 digits, divisible by 4? Is 50 divisible by 4? No. How can you say that? 4 into 10 is 40, okay. 4 into 12 is 48, okay. 4 into 13 is 52. So you can carefully see that there is no 50 in between them. Number 50 is not there in between them, so it is not divisible by 4. It is not divisible by 4, okay. What about this one? 729540? 40. Is it divisible? No. 40, is it divisible? Yes, not. It should be yes. It is divisible by 4. 4 into 10 is 40. 96, is it divisible? If you are confused, divide. 4 and 96. 4 2s are 8. And this 1, we have 6 here. 4 4s are 16. So we can say that, yes, it is exactly divisible. It is, just see, it is 6-digit number. No need to divide everything. It is enough to divide the last 2 digits to say whether the given number is divisible by 4 or not. The last 2 digits are 9 and 6, 96, and yes, it is divisible by 4. So that is how you can say whether a number is divisible by 4 or not. Okay, so the next one we're going to discuss about divisibility by 8. Again, it is a very important concept because it's not that easy. Okay, it is very easy if the number is more than 4 digits. Okay, what is the logic behind this one? A number with 4 or more digits, is divisible by 8 if the number formed by last 3 digits is divisible by 8. So last 3 digits in the number 4, we went for last 2 digits. Here we are going for last 3 digits. So let's try to understand more about that. The divisibility for numbers with 1, 2 or 3. The divisibility for numbers with 1, 2, 3 digits. Okay, 1, 2, 3 digits by 8 has to be checked by actual division. For example, it is a 3-digit number. We need to do normal division. But if it is a more than 4 or more than 4 digits, we can simply check the last 3 digits. That means simply whatever number you have, the last 3 digits are very important. Okay, see this one. 76104. Let us try to check whether it is divisible by 4, divisible by 8 or not. The last 3 digits are only required. No need to go beyond that. No need to find the complete thing. Okay, so 8 and 104. 8 1s are 8. 2 is left. 8 13s, 8 3s are 24. So yes, I can say that 104 is divisible by 8. So the complete number 76104. The complete number 76104 is divisible by 8. The complete number 76104 is divisible by 8. Right. Let's move ahead. Let's go for the next one. A number is divisible by 8 if the number formed with the last 3 digits is divisible by 8. Same thing. Okay. Let's see with some examples. 50456. So we need to check with 456. We need to manually check with the last 3 digits 456 with 8. 8 1s, 8 2s, 8 5, 8 4s 40, 8 5s 40. 8 5s 40. We are left with 5 6. 7 8s are 56. 7 8s are 56. Okay, so 8 into 57, 456, which is divisible by 8, which will give you 57. So divisible by 8. We're discussing about divisible by 8, and yes, it is divisible. It is divisible. Okay, next 729544. 729544. The last 3 are very important. 544. 544. So with 8 6 are 48, 8 7s are 56. So we have a difference of 6 and 4. 8 8s are 64, and yes, we can say that it is divisible. 8 8s are 64, right? So yes, 544 divided by 8 will give us 68, and yes, it is divisible by 8. In the same way, now we have just 3 digits. There is no digit before that. Done. Just check with these 3 numbers, 408 normal division as well as 424 the normal division, you can understand whether these are divisible by 8 or not. For numbers less than 8, less than 3 digit, we need to check for the complete number. But if the number is more than 4 or more than 4 digits, the last 3 digits are enough to say that whether it is a multiple of 8 or not. Right? Let's move ahead to say divisibility by 11, which is the most important thing here, as well as the most confusing thing. All the numbers what we discussed, we kept a small logic. Either it is an even number, or the sum is divisible by 3 or 9. If 2 and 3, 6 will come. If a number is divisible by 2 and 3, it is divisible by 6. In that way, we have discussed lot many things. But here, divisibility by 11 is completely a unique method. It's completely different logic. Let's try to understand what is that. A number is divisible by 11. Okay, we are going to discuss the divisibility rule of 11. Okay, if the difference between the sum of the digits, at odd places and sum of the digits at even places is either 0 or divisible by 11. Okay, if the difference means subtraction. Difference between two numbers. Which two numbers? Sum of all the digits in the evens place and sum of all the digits in the odds place. If you can add these two and then find the difference, it should be either 0 or a multiple of 11. So let's try to understand about that. 1, 2, 2, 1. We have a number 1, 2, 2, 1. From the right, let's try to see which are in odds places, which are in evens place. Okay, this in the first place, the second place, third place, and fourth place. We're having total 4 places. 4 places. 1 goes for odd place. Number 3 is also odd. 2 is even, and 4 is even. So sum of all the digits in the odd and even. So odd 2 plus 1. Odd 2 plus 1 will give you 3. And even 1 plus 2 again. Even 1 plus 2 again 3. So now tell me what is the difference of these two? 3 minus 3 is 0. Yes. It is enough to say that it is 0 or 11. We got 0. Number 1, 2, 2, 1 is divisible by 11. If you have doubt, let us verify. 1, 2, 2, 1 divisible by 11. Okay. Let me write it properly once again. 11 and 1, 2, 2, 1. 11 ones are 11, so 1 is left, 2 is left. 11 ones are 11, once again 1 and 1. 11 ones are 11. Yes, it is exactly divisible by 11. 11 into 1, 1, 1 will give you 1, 2, 2, 1. Right, simple thing. So let's move ahead to learn more applications based on this one. The one we are going to discuss is a palindrome number. Palindrome, what is that? Okay. A palindrome number is a number which on reversing the digits gives the same number. Palindrome number is a number which on reversing the digits gives the same number. Reversing the digits, that means when we are writing 1, 2, 3, 4, reversing means 4, 3, 2, 1. The order completely gets reversed. 1, 2, 2, 1. Just write in the reverse way. This one should come first, then 2, then 2, and then 1. In the same way, the reverse of this one, 1, 2, 5, 5, 2, 1 is exactly the same as this one. 6, 8, 5, 8, 6. 6, 8, 5, 8, 6. You can see the same number is being repeated. So, when the same number is repeated, even when you completely reverse the order, such type of numbers are called a palindrome. Okay. Every palindrome number with even number of digits, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3. Every palindrome number with even number of digits is always divisible by 11. So, if it is a palindrome and it is having even number of digits, don't worry, just you can directly say that it is divisible by 11, or else you need to go with the other techniques just we have discussed before. Okay, so what's the next one? Okay, which of the following numbers are divisible by 4? which of the following numbers are divisible by 4? So what do you mean by that? Number 4, what is the logic? Did you understand? Did you remember what is the logic for 4? The last 2 digits sum, the last 2 digits, not sum, just the last 2 digits should be a multiple of 4. Okay. 5, 72, 72, 4 and 72. 4 ones are 4, 3, 2. 4 8s are 32. So 4 into 18. 4 into 18 is 72. We ask 72, the last 2 digits is divisible by 4. The entire number is divisible by 4. 21084. 21084. The last 2 digits, yes. 84 is 4 into 21. 4 into 21, it is divisible. 60, that is a 4 into 15. Yes, it is divisible. So the entire number is divisible. So with number 4, just check the last 2 digits, it's enough. Just check the last 2 digits, it is enough. Right? So what is the next one we are having here? Which of the following numbers are divisible by 8? 8 we discussed. The last 3 digits are very important. So 774. Let us try to find that 774 with 8. So 8 ones are 8. No. 8 8s, 8 9s are 72. 8 9s are 72. So we have 5, 4. 8 7s are 56. 8 6 are 48. We are not getting a 0 as a reminder. So we can say that it is not. 9774 is not divisible by 8. It is not divisible by 8. Okay. What about this one? 531048. 531048. Carefully see here. The last 3 digits 048. Is it divisible by 8? Yes. All that is 0. We are left with only 48. 8 6 are 48. You know that, right? 8 into 6 is 48. Or you can write as 048. Both are same. If you are confused, let us try to verify that. 531048. Let me divide that with 8. 8 4s, 8 5s, 8 6 are 48. Okay, 8 6 are 48. How much we are left with? 2 plus 3. We are left with 5, correct? And then we have 1 here. So 8 5s or 8 6. 8 6 again. 8 6 are 48. Again it is a 3. Now it is 30. Is that correct? Once again, let us try to understand that. Okay. So 8 3s or 8 4, 8 3s are 24. So we are left with 6. And then we have 4. 8 8s are 4. 8 8s are 64. 0. And then we are left with 8. 8 1s are 8. And we get the balance 0. Yes, we got the remainder as 0. So we can say that it is exactly divisible by 8. Same way, 5500. Just check this 500. Whether it is divisible by 8 or not. If yes, the complete number is divisible. If not, the complete number is not divisible. Right. So let's move for the next one. Which of the following numbers are divisible by 11? Sum of all the odd digits and sum of all the even digits. Even digits in the sense, even places, odd places. Let's see that. So here 1, 2, 3, 4, 5, 6. All the even numbers add 1, 2. Okay, these 3 numbers. 8 plus 9 plus 8. 8 plus 9 plus 8. Tell me what is that? 25. It is a 25. All the odd digit places. 4, 1, 3 and 5. 5 plus 5, 4, 4. 5 plus 4 plus 4. 5 plus 4 is 9. 9 plus 4 is 13. So if you find the difference of these two. Once again. 8 plus 9, 17. 17 plus 8. 17 plus 8, 25, correct? 5 plus 4, 9. 9 plus 4 is 13. The difference, don't add these two. Difference of these two, 5, 6, 7, 8. 2 and this 1. No, it is not divisible by 11. So we can say that 8, 5, 9, 4, 8, 4 is also not divisible by 11. Okay. 10824. So now see here. 1, 2, 3, 4, 5. All the even numbers, digits, even placed 2 and 0. 2 plus 0 is 2. What about all the odd placed numbers? Odd. So this one 1 plus 3 plus 5, 4 plus 8, 12, 12 plus 1, 13. So the difference of these two, 13 minus 2, which is 11. Yes, it is exactly divisible by 11. Let us check that. 10824. So 11 ones, 11 we cannot. We need to go for 11 nines maybe. 11 nines, how much is that? 99. 11 nines are 99, so we are left with again 9. Then 2 will come. 11 eights are 88, then we are left with 4. And this 4 will come down. 11 fours are 44, and we got the balance 0. Yes, it is divisible. Okay, so 984, so it is divisible by 11. The same way you can also check for 20801. The same way you can also discuss for 20801, right? So let's move ahead. Let's try to see one more application. Verify whether the following numbers are divisible by both 4 and 8. By both 4 and 8. Let us try to see that. 2104. The very first thing is 04. Is it divisible by 4? With 4, yes. With 8, we need to go and check for 104. 104 and 8. 8 ones are 8 and 2 4. 8 13s are 24. And yes, you can say that 8 is also yes. So yes for both of them. It is divisible by 4 and 8. It is divisible by 4 and 8. Okay. What is the next one? Last 2 digits, are they divisible by 4? Yes. The last 3 digits, are they divisible by 8? Let us try to find that. 8 and 352. 8 and 352. 8 fours are 32. And this is 3, this is 2. 8 fours are again it is 32. So yes, it is divisible. With 8 also it is yes. And you can say that it is divided, it is divisible by both 4 and 8. In the same way you can go for 1800. 1800, 800, yes with 4. Okay, 0 is also multiple, 4 into 0 is 0. 800, 8 into 100 is 800. So yes with 800 also, 8 also it is yes. So we can say that yes, it is divisible by both 4 and 8. See, we are not actually dividing each and every number. We are just following some logics to identify whether numbers are divisible or not, right? So we have few more applications, so that this one you can take it as a take-home assignment. Find the smallest number that has to be added to 289279 so that it becomes exactly divisible by 8. For 8, no need to check the entire number, just check the last 3 digits, and see the nearest number to that, so that the complete number is a multiple of 8 or it is divisible by 8. Okay, so that is one question you can go for. And we have one more question. Find the smallest number that has to be subtracted from 1965 so that it becomes exactly divisible by 4. Exactly divisible by 4. So from these two lectures, these two questions, we can continue in the next class, and then after that we have a couple of more examples as well as concepts to be covered, so that we are going to discuss in the next coming class, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So today we'll be practicing a few questions regarding the chapter Fun with Electricity. Okay, so my name is Shashin Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. Okay, so the first question is a very simple one based on an electrical circuit. So here the question is this: an electrical circuit. Now look at the options. You have to select the best option. provides a path for current to flow, has to be a closed loop for current to flow, can consist of a cell, wires and a bulb, or all of the above. So what is the best suitable answer for this? Everyone think about it, read it carefully and then answer. A, B, C and D. A, B, C and D. So which is the best option in this case? Everyone? The correct answer is? The correct answer is option D. Okay, the correct answer is what? Option D, all of the above. Because see, first look at the first option, an electrical circuit. What does it do? It provides a path for current to flow. This is correct. Has to be a closed loop for current to flow. That is also correct. It should be completely closed. A loop will mean it's like starts and ends. Like this is a loop in simple case. It will start and it will also end at the same point. Yes, so it has to be a closed loop for current to flow. That is correct. Can consist of a cell, wires and a bulb. Now some of you might ask me, sir, what about fan? What about a fridge? All of them can also be there. So here the thing is can consist. So it's up to it. But yeah, it can consist of a cell, wires and a bulb. Yes. So all these three are correct. So that is the reason why the best suitable answer will be option D, all of the above. Is that clear? Yes? Okay, that's wonderful. So let's continue. That is the first question. Let's go into the second question. Which terminal is shown in the figure? Positive or negative? So this, you have to look at this. Which terminal is this? A or B? That is positive or negative? I'll give you 10 seconds of time. 10 seconds should be enough. So please answer that. Option A positive, option B negative. What is that? Everyone, 10 seconds are up. So which option is that? The correct answer is option A. It is a positive terminal. So how do we identify a positive and negative? For a positive terminal, you have a cap. This is a cap. Right, so wherever you have a cap, we have what? A positive terminal. So it is slightly above. The cap will be a projection. It will be projected up, slightly above. And obviously at negative terminal, what do we have? At negative terminal, we have a disk. And at positive terminal, we just learned, I'll again write it down. At positive terminal, we have a cap. So using a cap and a disk, we can identify the positive and negative terminals of a cell. Okay, good. Let's continue. Next question. Electric current can flow through metals. Is the statement true? Yes or no? What do you think? Electric current can flow through metals. Is the statement true? Yeah? The correct answer is? The correct answer is it is true. So the answer is yes. Why is that? Because metals are generally good conductors. Metals are generally good conductors. Or you can say just conductors of electricity. They allow current to pass. Current or electricity is the same. Right, so when we say they are good conductors of electricity, metals allow current to flow through them, to pass through them. So, electric current can flow through metals? Yes. Clear? Simple? Good. Next. Instead of metal wires, a jute string can be used to make a circuit. Is the statement true? Yes or no? What do you think? Yeah, everyone. Can a jute string be used? Now, jute string is mainly you will find that in villages, that brown colored thread. Even for festivals, we use it to sew together, right? So, the brown colored thread. So, jute string, can it be used to make a circuit? Yes or no? That is, instead of the metal wire, instead of copper wires, can you make use of a jute string? Yes or no? The answer is no, we cannot. Now why is that? Because jute string is an insulator. Jute string is an insulator. What does insulator mean? Insulator does not allow current to flow through them. Insulators do not allow current to flow through them. So that is the reason why we cannot use jute. Right? For current to flow, it should be a conductor. But jute string is an insulator, so it cannot be used. The answer is no. Clear? Good. Next question. Electric current can pass through a sheet of thermocol. Is the statement true? Again, a very simple question. Electric current can pass through a sheet of thermocol. Is the statement true? What do you think? Yes or no? Everyone. The answer is again no, because thermocol is what is an insulator. Again. So thermocol, where do we find thermocol? For packaging. Yes or no? And thermocol is an insulator. So it does not allow current to pass through it. Right? So electric current can pass through a sheet of thermocol? No. The answer is no. Clear? Simple. Good. Next question. It's a very interesting question here. Will the bulb glow? Explain. So in this case, will the bulb glow? You have a cell. You have a bulb, you have the wires, and you have an iron nail. So will the bulb glow in this case? What do you think? Yeah, everyone. Well, again, I'll give you 10 seconds of time. Yes or no? Yes or no? The time is up and the answer is yes, it will glow. Yes. Why? Because we have to look at the connections. Is the circuit closed? See, is it open anywhere? No, it is not open anywhere. Are the two terminals of the battery or the cell connected? Yes. Are the two terminals of the bulb connected? Yes. And is the iron nail, is it a conductor? Iron nail is a conductor. Iron nail used here is a conductor. What about the wires? The wires are also conductors. So everything is made up of conductors. They allow current to pass through them. It is a closed circuit, closed and continuous path for current to flow. That means it will allow the current to flow, and when the current flows, the bulb will glow. Obviously, we are assuming that the cell and the bulb are working properly. We are going with that assumption. Okay, so will the bulb glow? Yes. Okay, good. Next, in an electric bulb, light is produced due to the glowing of. Due to the glowing of what? We have options. The glass case of the bulb, the thin filament, the thick wires supporting the filament, and gases inside glass case of the bulb. What do you think? Yeah, everyone. What do you think will the answer be? Read the question and the options very carefully. Light is produced due to the glowing of what? What glows in this case? Yeah? What glows in this case? A, B, C, D. Which is the correct answer? The correct answer is B. The correct answer is B. What is the answer? Thin filament. Okay, the filament of a bulb glows. That is the one that glows, which produces light, which emits light. Okay, good. Next. In which of the following circuits, this is a very interesting question. In which of the following circuits A, B and C, circuit A, circuit B and circuit C, given in the figure, the cell will be used up very rapidly? What do you think is the answer? A, B and C. Where will the cell be used up very rapidly? Yeah, everyone. A, B and C. What is the answer? And the answer is option A. Now many of you might be thinking, why sir, here in the case of option C we have two bulbs, so it should be C. No. Now if you remember, in class we have gone into a simulation, and in the simulation we have seen that when there is no bulb, that is when the cell is connected only by wires, the cell will burn. The cell will burn. Right, that means the cell is used up rapidly, very fast. In fact, what do bulbs do? Bulbs decrease the current. Bulb will decrease the current. How and all not required, but bulb decreases the current. Bulb decreases the current. So one bulb, it will decrease the current. Two bulbs will mean they decrease the current more. Two bulbs will mean they decrease the current much more. So between B and C, between A, B and C, A uses up current rapidly because there is nothing here to decrease the current. So current will be very high and the cell will be used up very rapidly. That is the reason why cell will burn. But the other two cases, bulb will decrease the value of current. Clear? Good. Next, so the answer is option A. The answer is what? The answer is option A. Good. Let's continue. Next question. Why do bulbs have two terminals? Very interesting one. I'll give you 30 seconds of time, everyone. 30 seconds of time. So please think and write down the answer. And then you can compare your answer with mine. Why do bulbs have two terminals? Why do you think? What do terminals do? I mean, why can't a bulb have only one terminal? Why can't a bulb have 3 or 4 or 5 or 6? So what is the answer? Yeah? Yeah, 5 seconds more. 3, 2, 1, and the time is up. So why do bulbs have two terminals? Okay. Let me explain. The bulbs have two terminals because one terminal is for current to enter and the other terminal or the second terminal is for current to exit. So terminals are like gates. So through one gate you enter, through the other gate you exit. Through the same gate you can't enter and exit, not possible. So through one gate we enter, through the other gate we exit. Terminals are also the same way. Through one terminal current will enter, through the second terminal or through the other terminal current will exit. That is the reason why two terminals are required. That is the reason why two terminals are required. Clear? Good. Next. If the bulb is fused, look at the question here, look at the question. If the bulb B is fused, which bulb? Bulb B is fused. Now what are fused bulbs? You have to know. Will the other two bulbs glow when the switch is in on position? The switch is in on position. Here it is shown as off, but let's say that switch is in on position, the connection has been made. And then in that case, what will happen? When the switch is in on position, will the bulb A and will the bulb C glow because the bulb B is fused? I'll again give you 30 seconds of time. I'll again give you 30 seconds of time. So please tell, what is that going to be? Will the bulb A and C glow when the bulb B is fused? 10 seconds more. 5, 4, 3, 2, 1. The time is up. Will they glow? They will not glow. They will not glow. Why is that? See here. B is fused. What does fused bulb mean? Damaged. Damaged bulb. It could be damaged because of the filament. The filament could be damaged. The glass case could be broken. The connecting wires could be damaged. Anything. So B is fused. That implies current cannot flow through B. Current cannot flow through B. So if current cannot flow through B, that means, is it a continuous circuit? Through B it cannot flow. It cannot go anywhere through B. That means it is not a closed and continuous circuit. Circuit is not closed and continuous. It's not closed and continuous. So what happens? Current does not flow. Current does not flow, and when the current does not flow, A and C will glow. Sorry, A and C cannot glow. That's it. Understood? So these are the reasons. B is fused, B is damaged, current cannot flow through B. That means the circuit is incomplete. The circuit is not continuous. So the current will not flow, and when the current does not flow, the bulbs A and C do not glow. Clear? Simple? Good. Next question. Is it safe to touch the electric board with wet hands? Is it safe to touch the electric board with wet hands? Explain. What do you think is the answer? Yes or no? Is it safe? It's a pretty general question for our everyday life, so it's very important as well as interesting. So what do you think? Is it safe to touch the electric board with wet hands? No. No, the answer is a plain no. It is not safe because water, or let's say tap water, is a conductor of electricity. So, if water comes in contact with, if water on hands, wet hands, right? So there will be water on the hands. On hands come in contact with the wire. Come in contact with wires. Current can flow into the human body. Current, else if it comes into contact, current will flow through water into the human body, leading to electric shock. Into the human body, leading to an electric shock. Is that clear? Very simple. That is the reason why you should not touch any electrical appliance with wet hands. Why? Because tap water is a good conductor. So if you touch any switch or any electrical appliance with wet hands, your water, if, I'm saying it does not happen always, but if it happens, if water comes in contact with the wires, then the current can flow from wire through the water into our hands, from hands into our body. We can get an electric shock which can be life-threatening, That means it can lead to death. So be very careful, do not be negligent. Okay? Good. Next question. Is human body a conductor? Yes or no? Is human body a conductor? What do you think? Yes or no? Everyone. Is human body a conductor? And the answer is yes. That is the reason why we get shock. This is the reason why we get shock. This is the reason why we get electric shock. Because current can flow through us. Because current can flow through human body, that is the reason why we get electric shock. That means we are not completely safe. We are not safe dealing with electricity. We have to take proper precautions. Okay. Next. Current carrying wires are insulated. Why? Current carrying wires are insulated. Why? You can clearly see this is the wire, but surrounding the wire you have a covering, a rubber or a plastic cover. Why is that? Why are they insulated? Why, everyone? Why do you think? That is for, why? For safety purpose. For safety reasons. Now there are many reasons here. So that when we touch the wire, we will not get shock. For safety reasons. Or else you can also say that when two wires come in contact, current can flow from one wire to another. One wire to another. To avoid this, they are insulated. The wires are insulated so that, see, current cannot flow through insulators. Current cannot flow through insulators. So if the wires are insulated, current cannot flow through the plastic or the rubber covering through the insulator. So it is pretty safe. So main reason is for safety purpose. Even when you touch a wire, you should not get a shock so that they are insulated. Clear? Good. So that's it, everyone. So we ended a few questions, a few interesting and simple questions. Okay. So thank you. Thanks a lot.